When you're calculating the area of a triangle, you can use any of these three formulas where you know two side lengths and the angle between them, or you can use Heron's formula where you calculate half the sum of the side lengths and put it into that formula. I've got three examples here, so let's see what we can do in these. I guess the first challenge is sort of to identify what you have. Here I have two side lengths and the angle between them, so I'm going to calculate area equals 1/2 A B sine gamma. So the area equals 1/2 5.3 times 4.5 times the sine 43. So the area is approximately, the area is approximately 1/2 times 5.3 times 4.5 times the sine of 43. Now you just want to double check that in mode your calculator is in degrees. Then sine will give you the right value. And the area is approximately 8.1. Notice here I have the three side lengths. So this is a classic candidate for Heron's formula. Heron's formula tells you first to calculate A plus B plus C over 2. So we'll calculate 2.9 plus 3.8 plus 6.1 over 2. That's approximately 2.9 plus 3.8 plus 6.1 divided by 2. Well, not approximately, exactly 6.4. Okay, so now what I do is I take the square root of 6.4 times 6.4 minus A, 6.4 minus our 2.9, so that's 3.5. 6.4 minus B, 2.6, and then 6.4 minus C, 0.3. Okay, so put that all together, and I get the square root of 6.4 times 3.5 times 2.6 times 0.3, which is here approximately 4.2. Okay, one more example. Notice here I have angle, side, angle. Now you know that you can solve a triangle like this using law of sines. This doesn't fit into any of our categories automatically. So what do? Well, I work to find enough information so that I can either use Heron's formula or one of the more basic areas of a triangle formulas. Notice that both of those require at least two sides. Well, how would you get started here? Since I know two angles, gamma is going to be fairly easy to find. Gamma is 180 minus 59 minus 62. That says it's another 59-degree angle. Now at this point, you can actually use a little bit of mathematical cheat. Notice this is an isosceles triangle. That means this side B is going to actually be 17.2. Equal angles gives you equal side lengths. If you didn't know that, you could still use law of sines to find that. Look and see what that looks like. Sine of 59 degrees over 17.2 equals sine of 59 degrees over B. Okay? And this would work for anything, but it shows you an interesting property of isosceles triangles. Okay, so cross multiplying, you get B sine of 59 degrees equals 17.2 sine of 59. Divide. And of course, if you didn't have 59 and 59, this would give you side length B. It just so happens that here I get a calculation that's so easy. Sine 59 over sine 59 is 1, so this is 17.2. Whether it's easy or not, you get side length B, side length C, and you have alpha. Now you're ready to find the area. So there might be some work before you can use one of the area formulas, okay? So now it's 1/2 BC, 17.2 times 17.2 minus, times the sine of 62 degrees, okay? So I'm going to type that in, 1/2 times 17.2, I'll just write squared, times the sine of 62 degrees, gives me an area that's approximately 130.1.